Hello everyone. Let's talk about the probability calculation in R in this lecture. I want to introduce two concepts to everyone: the binomial distribution and the normal distribution. These are frequently used probability calculation equations in practice. They are also very helpful to address some business analysis questions. So let's take a look at them one by one. Binomial distribution. I want to use an example to show everyone how to use this probability calculation. Let's say we want to toss 10 coins together. What is the probability of getting 6 heads once the 10 coins land on the ground? Some classmates are very smart. They can immediately get the answer 50%, right? But is this a correct answer? No. 50% is only the probability of getting a head on one coin. We cannot apply this probability to 6 heads among 10 coins. If you want to challenge this idea, I suggest everyone to get 10 coins and then toss them to the ground. Sometimes you can say you get 1 head among 10 coins. Sometimes you can get 7 heads among 10 coins. No matter what, the probability of getting 6 heads among 10 coins is certainly not 50%. So what should be the answer then? We need to use the binomial distribution to calculate the answer. Let me show you how to use the binomial distribution first, and then I will explain it to everyone. Let's go to the R software. The function name for binomial probability calculation in R is dbinom. Let's type it in, dbinom. We have 3 parameters for this function. First, the parameter x. X equals to 6, which means 6 heads we want to get once the 10 coins land on the ground. Next, we have a size parameter. Size equals to 10. This means we have 10 coins totally. The third parameter, which is the last parameter, is called a probe. Probe equals to 0.5. 0.5 in this case is the probability of getting a head on each coin. After we identify these 3 parameters, we can see the result. Let's press enter to see the result. From the binomial distribution probability, we can say the probability of getting 6 heads among 10 coins is 21%. It is not 50%. If you look at this question again, you can find that there is a rule we can follow when we use the binomial distribution, right? The rule is, we already know the probability of getting a head on each coin, and the probability on each coin is the same. Then the binomial distribution can help us to calculate the probability of getting certain number of heads among a group of coins. You can see some similar questions in business analysis as well, right? For instance, if you already know the probability for a customer to purchase product ABC is 50%, then you can use the binomial distribution to calculate the probability that 85 out of 100 customers would buy product ABC. Here are some important information you want to remember for the binomial distribution. The binomial distribution is to help us to calculate the probability of getting certain results in a group. This group is consisted of several objects: a group of coins, a group of customers, a group of students, and so on. Each object in this group can only have 2 outcomes: either a head or a tail, either a success or a failure, either a positive outcome or a negative outcome. Then the binomial distribution can help us to calculate the probability of getting certain results among the group. Let's use these rules and use the binomial distribution to calculate another example. Let's say we already know the probability for a customer to purchase brand ABC is 50%. Now we want to calculate what is the probability that 85 out of 100 customers would buy product ABC. Let's use dbinom function in R. Let's type in dbinom and then parentheses. We have three parameters. First, x. X in the new case equals to 85 now. And then a comma. Next, size. Size in the new case equals to 100. The third parameter should be prob. We assume that the probability for each customer to buy product ABC is 50%. So the value for prob in this case is 0.5. Let's press enter. Now we can see 1.998 times e with the power of negative 13. E in R represents the value 10. 10 with the power of negative 13 represents a very small number in mathematics. If you use 1.99 times a very small number, you will still get a very small number. What does this mean? This means even though the probability for a customer to purchase product ABC is 50%, but if you want to get a group of customers who will buy product ABC at the same time, the probability is very small. The probability for 85 out of 100 customers would buy product ABC is so small that it's very close to zero. This is how you use the binomial distribution to perform some data analytics. Here I want you to pay attention to 2 points about the binomial distribution. First, the value for the prob parameter is not always 50%, not always 0.5. In the tossing coins example, the probability for us to get ahead on each coin is 50%. That is the hard natural fact. Nobody can change it, right? So we give a 0.5 as the value for prob. However, in other cases, the probability for each object to have certain result is not always half-half, 50%, 50%. For instance, if a customer really like a product, the probability for this particular customer to buy the product could be higher than 50%. Let's say I really like an Android phone. I really want to pay for the Android phone. The probability for me to buy the Android phone could be 80%. In those cases, the value for prob should not be 0.5. It should be 0.8. This is the first point I want you to pay attention to. The probability for each object to receive a desired outcome is not always 0.5. Could be different values. The second point I want you to pay attention to is that sometimes we'll use a variation of the dbinom function. It's called a p-binom, as you can see on this slide. The purpose of p-binom is to calculate a cumulative probability for a group. It is still a way of calculating a probability for a group, but this time p-binom will set up a standard and then calculate the probability for each scenario below the standard and then add the probability together. That will be the cumulative probability for a group to get a result based on each object probability. In our case, by using the p-binom, we want to calculate the probability of getting 6 heads among 10 coins. the probability of getting 5 heads among 10 coins, and so on and so forth, until we finish the calculation of getting no heads among 10 coins. And then we want to add those probabilities together. That will be the cumulative probability for this p-binom calculation. The purpose of the d-binom is to calculate the probability of getting exactly 6 heads among 10 coins. But the purpose of p-binom is to calculate the cumulative probability for the 6 heads standards. This is the difference between the two. Also, notice that when you use the d-binom function, the first parameter letter should be x. But when you use the p-binom, the first letter parameter should be q. This is another difference between the two functions.